Morning, everyone. What is everything made of? To answer this question, first we start to do the do now. This is a 1 minute activity. Write everything you know about the image below as a mind map. So after 1 minute, you have to stop writing and listen carefully and tell your answers. If you mention that this image is about the periodic table, and it contains the elements. On the elements, you can find the mass number, atomic number, the symbol of the element. So today we're going to discuss about the atomic structure and ion. That is the title of the lesson, but first we'll dive into the atomic structure. Here you can see the learning objective. After this lesson, we are able to describe and draw the structure of an atom, and we can label this as well. We can also identify and describe the subatomic particles in an atom and their position, explain the electronic configuration, and you understand the ions formation. So what is the smallest unit of matter? As we know, everything is made up of matter. So what is the smallest unit of matter altogether? Once again, yes, that's the correct answer. This is atom. So when we're going to see the atom, so what is an atom? Let's see its definition. So the smallest unit of element that retain its chemical properties. We call this atom. But here we can see oxygen gas and oxygen atom. When we're going to see the atom, we have only one element. While when you're going to see a molecule or oxygen in a gaseous state, it's a combination of two atoms. So the another question here, imagine if I remove something tiny, very small from an atom, can I change the entire behavior of an element? So yes, that's the true answer. Definitely it will going to change. So before to answer and give a detailed explanation of this one, first let's see the atomic structure. An atom has a central nucleus. This part you can see here, we call this nucleus. This is surrounded by the electrons arranged in shells. We call them as energy levels. And here you can also see three subatomic particles. These are basically the fundamental particles. There are many other particles, but these are the three fundamental: electron, proton, and neutron. So first we're going to see the nucleus. This is the middle one of the atom, in the middle, or you can say that in the center. It contains proton and neutron. It means two subatomic particles are present in the center of the atom. And this nucleus has a positive charge on it because due to the presence of proton, and proton carry positive charge on it. This is the reason why the nucleus is positive. Almost the whole mass of the atom is concentrated in the nucleus. The weight of the atom and all the stuff that is solid that is present inside the nucleus. The third subatomic particle we name as an electron. So these, you can see that revolving around the nucleus, they contain a negative charge. Then they are tiny, but they cover a lot of space. So you can say that just everyone has their personal space. So they have their space. Then the volume, their orbits occupied determine how the big the atom. For example, if an element or atom has only one shell, it's smaller as compared to the atom who has two shell. Okay. Then they are virtually no mass, but they occupy shells around the nucleus, which we name as energy levels. So to understand the atomic structure, here I give you the example like a pen. So when you're gonna pronounce the pen, and the spelling of the pen is P-E-N. P represent here proton, and P for positive, the charge. Second, E, electron, and it contains or carries a negative charge on it. The third subatomic particles we call as neutron, and there is neutral, or you can say that no charge. So it's the simple way to remember this atomic structure and the subatomic particles, which we name as proton, P positive pen, E electron, negative, and neutral or no charge. So you have only 1 minute. You can pause the video here and draw or label this diagram by the help of using these words that I gave you over here. After 1 minute, you can easily find out the central part, which we name as nucleus. The positive charge, these are the protons. The neutrons, where there is no charge, neutral. Electrons are present in the shell, or we call as them energy levels. Here is another question. Is the atom solid like a ball? So the answer is no. Now the next one, this is a summary of the subatomic particles. Just go through them, then we're gonna move to the next part here. So these are the two simple numbers. We just need to know them. One is the atomic number and second is the atomic mass. So for example, when you see an element like sodium, you can see here two numbers. One is 23 and second is 11. What these two numbers represent? The 23 represent the mass number. This is the total number of proton and neutron, while the 11 representing the atomic number, and this is the number of protons, and this also we can call equals to number of electrons. Here is a misconception. Let's first try to resolve this. So the atomic number is only the number of protons, and these are equals to number of electron, while the mass number is the number of protons. This is the combination plus number of neutrons. This is very important point. Keep it in your mind. Next, atomic number tells the proton. We already know this. Second, the also tells how many electrons, because protons are equals to electrons. Next one, to get the number of neutrons, we just subtract the atomic number. For example, the mass number is 23. You just take away 11 from it, subtract this, and you will get 12. That's the answer. And this is the mass number, and we can say this is the number of neutrons. The mass number is always biggest, and mostly or roughly you can say that it's double the atomic number. Now, next here, we can also call them as nucleons. And this nucleons, as we have two subatomic particle in it, proton plus neutrons, and we call as represent by a symbol A, while the bottom number, which is the atomic number, this is called the proton and it is represented by the symbol or the letter Z. So this one you can say atomic number and the mass number. Now here how we can find the number of neutron. Simply you can take in that way atomic mass minus atomic number and you can get the number of neutrons. If I change proton, do I get the same elements? Again, the answer is here no, because these are very unique numbers and there is no element they have same atomic number with anyone. It is just like our fingerprints. These are unique. They are not going to resemble anyone in this universe. So you can pause here a video for a 3 minute. Use your periodic table to complete that one. The first I'm going to do for you, rest you have to do yourself. So the number of protons is 50. As we know, this is the atomic number and we know protons equal to electrons. 50 is here, and number of neutrons simply atomic mass minus atomic number, and I can get the number of neutrons. Next we can see about the electrons. So electrons always occupy shell, or we call them the energy levels. So here is a rule. Let's start to see this rule. The lowest energy level always filled first. It's just like a ground floor in a building. So mostly people can go there, live there, buy there. It's easy, accessible, and they will not need to spend more energy on it. While the number of electrons, how they can accommodate, it's depend upon this rule. So the first shell, maximum electrons 2. This is the capacity. Then second shell 8 and third shell also accommodate maximum 8 electrons. That's the rule. Okay, so almost atoms are much happier when they have full electron shell. That's the most important point. So mostly we feel satisfied when we are not hungry and we are not thirsty. So if they are filled, their outermost shell, then they feel happier. Now, in most atoms, the outer shell is not full and it makes them want atom to react. So the reactivity depends upon the outermost shell. And if is it not filled, then they have to do this. So here is another question. How do we know how many electrons, protons, and neutrons there are? Again, open the periodic table, simply find the atomic number equal to the number of electrons. Take away from atomic mass, you can find the number of neutrons. Quite simple. So this one is a table again for you. You can pause here video for 3 minutes and complete that one by using your periodic table. The first one I'm going to do for you, like this one, Cl, chlorine, atomic number is 17, and electronic configuration. I know the rule 2, 8, 8. So in first shell, 2 electron, second shell, 8 electron, 2 plus 8, 10, remaining 7. So in the outermost shell, it has 7 electron. So in that way, you can complete this one. Next here, the second part of the session in which we're going to discuss about the forming ions. But before to do this, first you have to draw and fully labeled diagram of an atom lithium. In this you can see the electrons are 3. So it's mean electrons, they are also equal to protons. So if 3 electrons, it's mean it has 3 protons and it's the atom. So it's a 3-minute task. After completing this, what you have to do, swap with the person next to you. Assess their diagram by providing a positive feedback of an idea for improvement. So for example, I know this lithium, that's the symbol, its atomic mass is 7 and atomic number is 3. So I know that it has 3 proton, 3 electron, but the number of neutrons are here 4. So I need to draw first shell 2 electron, and in the second shell 1 electron. I have 3 protons and here 4 neutrons. So this is the fully drawn label diagram of lithium. Next one here. So I'm just going to repeat the word that we use, pen. So you have 30 seconds to complete. Even the starters are here like P, proton. Okay, so what is this? This is the atomic number. E, electrons equals to number of protons, and N, the mass number, take away bottom number. Okay, so the next one is here about the atomic structure in which we're going to match them. So the nucleus contains 2 subatomic particles, as we know, proton and neutrons, while electrons are only subatomic particles that can be lost or gained to form ions. So let's see about the ions here. Again, you have a small task in which I'm going to give you 1 minute to answer the question. Which of the following is the most stable? So the answer is here, full outer shell. It's mean this element is stable. The reason an element is in its most stable form when it has full which shell? Outer shell, okay, of electrons, unless the element in group 0. While in group 0, it will gain or lose electron to become stable. So we know that atoms want to become stable themselves by gaining and losing of electron, and in this scenario they become form ions. So here we can see that what is an ion. First of all, we know that an atom is neutral. Why? As we know, protons are equals to electrons. So how many protons? Positive charge equal to same number of electron, negative charge, they're going to cancel each other. But due to any case, if an atom lose electron, so it means it become a positive ion. Positive attitude, it's mean cation. To remember this, whenever you're gonna write the name CAT, this T make a positive sign. Okay, so you have to know that it has a positive charge cation, and when it gain electron, it become an anion. So let's see this one here. You can pause video here again for 3 minutes, and this task you have to do. Two things you have to do here. Number one, to complete the structure of the following elements below. Number one, who done this? Then the challenge for them. Can you think a rule for working out the charge of the ion for group 1, 2, and 3, and group 4, 5, and 6? How you can give them? You can take any element like here, for example, calcium. So what is going on here? First you have to see the group from the periodic table, what it have to do, which kind of activity is going to perform, gain or lose electron. Obviously it's lose electron, then it means it gain a positive charge, but how? So to understand this, after 3 minutes you can see the periodic table for the group. So group 1, 2, and 3, these are in, you can say that as we discuss them as metals. So group 1 lose electron to become a stable, forming a positive charge ion, while group 2 it's going to lose 2 electron because it has 2 electron in the outermost shell, and then it forming 2 positive charge ion. But when you move from group 5, 6, and 7, they're going to gain electron. Let's see, in group 7, chlorine, it has 7 electron in the outermost shell, so it gain 1 electron. By gaining 1 electron, it become to form a negative ion with -1 charge. Okay, now so here you can pause the video for 3 minutes and think about that, which one is more stable. And also you have to explain the reason. After 3 minutes, we can see that neither of them is stable. Why? The reason, let's discuss them in detail. For example, you can see this is the sodium. This is the atomic structure, sorry, the electronic configuration of sodium. First shell, 2 electrons, second shell 8, and third shell 1 electron. To stabilize, sodium loses 1 electron. By losing the electron, it becomes a sodium Na positive. So it will convert to a stable noble gas configuration to achieve that one. So this we also known as octet rule. According to that rule, if an element has 8 electrons in its outermost shell, it becomes stable because all the noble gases that we have in group 0, or we call group 8, which we also name as noble gases, they are unreactive and they are stable. Now let's see in case of chlorine. Here it has 7 electrons in the outermost shell. So by adding 1 electron, it becomes 8 and it converts into chloride ion. So stable octet achieved by gaining electron. Now here we have exam type question. Again, you can pause here the video for 4 minutes and find the answer of these one. So the question is here, calcium chloride is an ionic compound which contain calcium ions +2 and chloride ion -1. The diagram on the left represents the electronic structure of chlorine atom, while complete a similar diagram on the right to represent the chloride ion. So what you have to do, as we know that it has 7 electrons in the outermost shell, by gaining 1 electron, what happened? There will be 8 electron in the outermost shell. I'm just going to draw this one in that way. So 1 electron, you can say that here 2 electron, and this one you can say comes from anywhere else. So it's convert as a Cl chloride ion. Second question, explain how calcium atom change into calcium ion which has +2 charge. So about this, you can see that calcium belongs to group 2. It's mean it has 2 electron in the outermost shell. By losing its 2 electron from the outermost shell, Ca calcium gain +2 charge, because after that the inner shell has complete octet. It has 8 electron in it. So this gives you the understanding about calcium and chloride ion. So here you're going to discuss about few exam questions. Define atom, smallest unit. Why atom is neutral? Because protons are equal to electrons. Sodium electronic configuration. So you can see the atomic number 2, 8, 1, 11 electron. Define ion, atom gain and lose of electron. Difference between cation and anion. So cation positive, because here I mention that positive charge and anion is a negative ion, by losing electron, by gaining electron. So the summary: atom consists of subatomic particles, electrons changes form ions. This explain bonding and reactivity. Sodium form Na positive, not Na positive 2, and why noble gases are stable. Thank you very much.